is at ultra slow motion. In the paper in which we discuss these red-gray chips, you'll find a reference to this AMTIAC quarterly journal. This is kind of exciting. Okay, figure 1 talks about the applications for this. It's called nanocomposite. Nanothermite is an example of it. These guys, Livermore, thermobaric warheads, and then down at the bottom, a shaped charge. Can you see that? Let's see if I can use the pointer. So you see this is hollow here. Here's the material like C4, conventional explosive, in a shape such that when it explodes, you get a blast of gas, and then typically there's a copper liner also there, so that you get molten metal blasting out to cut through steel. That's how shaped charges work. See the shape there? It's kind of a cone, or if you linearize that, it becomes this wedge that forms the shaped charge to cut through steel. That's how buildings are demolished. Now notice what they're saying about the fuse right here on the end. See, they're pointing to that. The fuse or initiator, they're recommending a nanocomposite or nano intermetallic, of which a prime example is discussed in this article, which is a Department of Defense article, US, is nanothermite, nanocomposite as the fuse or initiator. In my opinion, this is the more likely context in which nanothermite was used in the World Trade Center buildings. Obviously, to find out for sure, we would have to either find unignited, well, we have the unignited nanothermite, but I mean unignited shape charge, which is unlikely. All that's been hauled off and melted, all that steel. Or find someone who knows, ask the questions, the tough questions, and get them subpoenaed. So here's the picture I'm suggesting now. This is my best thought of how nanothermite was used in the World Trade Center. It was used in these shape charges. In the top center, you see a shape charge, conventional, being applied to a steel beam. Isn't that amazing, this line? It must be about a centimeter, a couple centimeters wide, and then across the beam, electrically set off, and that cuts through that huge steel beam. See? It's remarkable. Just remarkable. On the left, lower left, you see an example from the World Trade Center, which is quite interesting to me. But of course, that steel is no doubt melted. That's what they did with over 99.7% of the World Trade Center steel. It was melted. It was sent to Asia, melted, destroying the evidence. We have the dust. We can learn a lot from the dust. But I'm suggesting that the nanothermite would appear then as a fuse or initiator. Now, why would you use nanothermite? Here, this is from Los Alamos, another national laboratory in the United States. I've worked at the lab as a postdoc for years. What they are talking about here is superthermite matches. So you have the nanothermite, also called superthermite, in these silvery globules with 2 wires, you see. You simply send a current through the nanothermite and it sets it off. Applications, according to Los Alamos, include triggering explosives for demolition. I'm not making this up, students. This is straight out of the publication, 2003, which you can find from Los Alamos National Lab. Why would you want to do that? First of all, you can touch this off electrically, this stuff, this nanothermite. Secondly, the superthermite matches are safer to use because they resist friction, impact, and heat, thereby minimizing accidental ignition. That's why you would want to use this. If you're worried about things going off prematurely, here's your solution. Plane hits building. We don't want too much to go off. Oh, superthermite matches. So then I got thinking, you see, why don't I try putting a voltage across this, one of these red chips from the building? I wish I had that on video, but I was acting alone. I've lost my position at the university, but I was acting alone with a car battery and these 2 sharp probes and a 12-volt battery, you see. And I touched one of the, I'll get it on video here, and I've recommended it to Mark Basil. He's set up better in Massachusetts. But he was skeptical at first as I talked to him, but he's convinced now that there's this explosive pyrotechnic material in the World Trade Center dust. So you touch the 2 probes, apply the 12 volts. I was holding it by hand, the 2 probes on the red chip, and it just went And of course, I backed up very quickly. And I decided in the future, this is just a little chip about, I mean, less than a millimeter square, you know, it's tiny. And I will have to have some, you know, remote way to do this. I figured out a way to do it. Another thing, by the way, I sent chips by U.S. mail to a post office box in the Midwest to a scientist. When it got there, and this was on an inner envelope and an outer envelope in a plastic vial that was closed tight. 2 little chips. When it got there, the scientist opened his post office box, and as he checked, there was a slit in the outer envelope. There was a slit in the inner envelope that lined up. The vial, as he removed it, the chips were absent. U.S. mail. I feel like we have, you know, Big Brother watching a little bit. Now, I sent, in that case, I told him, okay, the chips are coming. By email, I was communicating. More recently, I've sent chips quietly to Europe and an independent lab in the United States, and they did both arrive. I just didn't tell them I was sending them. And then they arrived, and they say, well, what's this? And of course, then I could tell them. Here's again from Los Alamos about these super thermite electric matches, showing them going off. By the way, a colleague, I just got to tell you, a colleague asked Los Alamos, can you give us a sample of this super thermite match? You know, you have photos of it, you have papers on it. What I wanted to do is take one apart and look inside and compare it with the World Trade Center red material, you see. Los Alamos, not only did they decline to send it to us, they said, well, we really don't have any of these. So I don't know. And so I see photos and it looks like they exist. Maybe they were just faked. I don't know. But how could they set one off without having one? I mean, this is, I'm getting to be real skeptical. I'm sorry. We'll carry on. Oh, to make this stuff, this is just to get at the aluminum. The nanoscale aluminum requires sophisticated equipment. This is not caused by a building just falling down and magically aluminum is in platelets with silicon passivated and the iron oxide in uniform granules embedded, uniformly mixed, and embedded in an organic matrix. No, where does all the organic come from, by the way, if you have a building falling down? No, it's just crazy, that idea. I just am again appalled. There's some scientist who said that, and do you understand what you're saying? I mean, look at the complexity of making this stuff. So where could it be made in 2001? That's a key question. It turns out there are not many labs that have the capability to make this nanothermite, especially back in 2001. Conclusion, who made the stuff? Why has NIST refused to look for explosive residues in the World Trade Center dust? Also, USGS would not answer my questions about that. Okay, here's something I want to emphasize, students. We can learn a lot from physics and experiments, but how they were used, exactly who did this and how they were used, I keep getting that question. You must understand that observing this red-gray material doesn't tell me. There's no fingerprint on this little stuff. We need subpoena power. We need an investigation, perhaps, I think, at an international level. Some government, this was suggested by Bray Antcliffe, did I pronounce it more or less right? And his colleague, both of them lawyers, I hope I'm getting that more or less straight, Bray, that this would be something where, okay, a nation such as Australia, Japan, that lost citizens in the 9/11 event could ask questions of the U.S. government, request, demand samples of the steel, of the dust from official sources, right? USGS, we want that dust to look at for ourselves. We want some of that steel that WPI has. We want the computer model that NIST did. We will have our own scientist test. We want to know what killed our citizens on 9/11. The U.S. Congress is rather obviously not going to, I'm sorry to say, proceed on this. maybe we can get the door to open if we pull it instead of push it. You know. This is what happened to steel. It went into a lot of it, some of it went into this USS New York, this huge warship. You might have seen that in the news the last several days. Who sacked Mineta? It was Cheney. Did you know that? As his testimony came out, he was asked to retire or something, but he was sacked by Cheney. O'Neill, let me just say, Paul O'Neill, the Secretary of Treasury, he challenged Cheney on wanting to go into war with Iraq, which was announced in January as Cheney and Bush took office. He opposed Cheney when Cheney said deficits don't matter. Have you seen the U.S. deficit lately? It's going like that. The deficit, I mean, it's gone from 5.8 trillion, I checked, when Bush Cheney took office. It was about double that when they left, and then now it's up to close to 12.5 trillion. I mean, it's hard to keep up. The deficit is just going crazy. P.S. Don't sell your coal for U.S. dollars. Just a thought, just a thought. Okay, demand gold for your coal. Okay, just a thought. He was fired by Dick Cheney.
And what happened at President Bush's very first National Security Council meeting is one of O'Neill's most startling revelations.
From the very beginning, there was a conviction that Saddam Hussein was a bad person and that he needed to go.
He says that going after Saddam Hussein was topic A 10 days after the inauguration, 8 months before September 11th.
From the very first instance, it was about Iraq. It was about what we can do to change this regime.
Now, everybody else thought that grew out of 9/11.
No.
But this book says it was day one of this administration.
Day one, these things were laid and sealed.
As Treasury Secretary, O'Neill was a permanent member of the National Security Council. He says in the book he was surprised at the meeting that questions such as why Saddam and why now were never asked. It's all about finding a way to do it. That was the tone of it. The president saying, go find me a way to do this.
For me, the notion of preemption, that the U.S. has the unilateral right to do whatever we decide to do, is a really huge leap.
You're giving me the impression that you're just going to be stunned if they attack you for this book. And they're going to say, I predict, you know, it's sour grapes. He's getting back because he was fired.
Well, I think I will be really disappointed if they react that way, because I think they'll be hard put.
But are you prepared for it?
Well, I don't think I need to be, because I can't imagine that I'm going to be attacked for telling the truth. Why would I be attacked for telling the truth?
So now we look at this question of Secretary of Treasury in 2001 as the Bush-Cheney administration took office. He was the Secretary of the Treasury, Paul O'Neill. And he reports, as we see in this video, that from the very first instance it was about Iraq, quoting O'Neill, the president saying, go, find me a way to do this, to going after, getting into attacking Iraq. Now, O'Neill challenged this idea of attacking Iraq, and specifically he challenged the shift to preemptive war, which was promoted by Dick Cheney and others. When Dick Cheney said deficits don't matter, a famous statement, Paul O'Neill opposed that as the Secretary of Treasury. He thought that was not wise policy. As he opposed these policies by Cheney and Bush, he was fired by Dick Cheney in 2001. I think this has some relevance as to what happened to me, as we shall see. I am often asked, what happened at your university? I'd like to answer that briefly. Of it. These guys, Livermore, you know, thermobaric warheads, and then down at the bottom, a shaped charge. Can you see that? Let's see if I can use the pointer. So you see this is hollow here. Here's the material like C4, conventional explosive, in a shape such that when it explodes, you get a blast of gas, and then typically there's a copper liner also there, so that you get molten metal blasting out to cut through steel. That's how shape charges work. See the shape there? It's kind of a cone, or if you linearize that, it becomes this wedge that forms the shape charge to cut through steel. That's how buildings are demolished. Now notice what they're saying about the fuse right here on the end. See, they're pointing to that. This, the fuse or initiator, they're recommending a nano composite or nano intermetallic, of which a prime example is discussed in this article, which is a Department of Defense article, U.S., is nanothermite. This is at ultra slow motion. In the paper in which we discuss these red-gray chips, you'll find a reference to this AMTIAC quarterly journal. This is kind of exciting. Okay, figure 1 talks about the applications for this. It's called nanocomposite. Nanothermite is an example